Good day everyone. Let us see today a different maxima minima statement sum. Okay, let me read that sum first. A given quantity of metal is to be cast into a half cylinder with a rectangular base and semicircular ends. Show that when the total surface area is minimum, the ratio of the length of the cylinder to the diameter of its semicircular ends is pi is to pi plus 2. Before proceeding to the sum, let me tell you certain facts. Now this is also a cylinder, right? Now when I hold like this, we call this as the height and this will be the base circle and the diameter like that. But if I hold like this, we call this as the length of the cylinder. So it depends on the position how we take it. So that is the thing here. The length of the cylinder is nothing but the height if we hold it the other way. Then there is something called Hof cylinder. That is, now it is a cylinder. If I cut it like this, into half, that is called a Hof cylinder. So you should know how the Hof cylinder will be and how we have to consider the total surface area. So you should know that, then only you will be able to do the sum. Okay. Now see this one. This is a Hof cylinder. Now I will tell you. See, this will be the base. Okay. What is the shape? This is a rectangle. Then you have a semicircular end here. Similarly, you have a semicircular end on the other side. Then if you see here, you have a curved surface. So actually you can take this one has one flat rectangular surface. It has two semicircular ends and it has a curved surface. That curved surface will be actually half of the curved surface of the cylinder. So this is a half cylinder. So you should be clear about this because we are going to deal with this half cylinder now. Now, in this sum, it is a half cylinder and what is given to us is a given quantity of metal. That means the volume is constant. The volume is given and that V is constant. So that is the thing given here. You are casting that into a half cylinder. Now you know that half cylinder is having a rectangular base and semicircular ends, two semicircular ends. Okay. Now what you have to show that when the total surface area is minimum, so you have to minimize the total surface area. What you have to prove? The length of the cylinder, that is half cylinder, to the diameter of its semicircular ends, that is pi is to pi plus 2. So this is the sum. So now our figure is a half cylinder. So whether it is a cylinder or half cylinder, we should know the R will represent the radius, right? R will represent the radius of the base. That is, two sides you have two circles. That R is the radius. Then here, the H, here it is length because we are holding it that way. It is length of the half cylinder. Length of the cylinder or half cylinder, both are same here. So, the H we take as the length. Then V we take as the volume because that is given. So the volume is V. Then S is the total surface area. We want to minimize that. So it is the total surface area. So these are all the letterings you should know. Okay. Now what is given here? The given thing is the volume V is given. Volume V is given. V is constant. So whatever is given, that is a constant, you should remember. So now the figure I haven't drawn because I have showed you. So now this is the Hof cylinder and this is what is given. Now what we are going to prove? To prove the ratio of the length, that is h, okay, is to the diameter. So you know the diameter is 2r, radius is r, so the diameter is 2r. H is to 2r is equal to pi is to pi plus 2. This is what you have to show when the TSA, that is the total surface area, is minimum. So now we have finished the understanding part, the lettering part, the given and to prove. So now straight away we have to go to the proof part. So first remember how a Hof cylinder will be. So I have explained it to you. It will have a rectangle at the base, okay. It will have two semicircular ends and it will have a curved surface area which will be half of the curved surface of the cylinder. Then you know what is given, you know what is to be proved. So now let us come to the proof part. In the proof part, I have already told you in many sums, you have to first consider what is the constant thing, that is what is given. So now V is given, so write that formula. Now it is a Hof cylinder, so that volume will be half of the volume of the cylinder, so that will be half pi r squared h, okay. V will be equal to half pi r squared h. Now you know you have two variables r and h, so you have to convert one variable in terms of the other variable and the constant. So keep the h here, you will be getting 2v by pi r squared. So now the h you have expressed in terms of v and r, mark this as 1. Now what we have to maximize or minimize now? The TSA. So let us take that formula now. Now we want S. This is the TSA of the Hof cylinder. Now you should have in the mind what are all the things it has. It has a base rectangle, okay. It has two semicircular ends. So two semicircles means it is one circle we can take. Then you have the curved surface area. So now I will write S is equal to, for you to understand I will write area of base rectangle, okay. This is one we have to consider, plus area of two semicircles. These are the two semicircles in the two end, plus area of curved surface, okay. So these are the three things you have in the Hof cylinder. So now the area of the base rectangle, when you come to that, now this is the base rectangle. If you see here, this one, no, the length of the rectangle is nothing but the length of the cylinder, that is the Hof cylinder. So now that will become your h, okay, into the breadth is equal to the diameter of the semicircle. Do you follow? The breadth of the rectangle is diameter. So now that will be 2r. So this will be the area of the base rectangle, plus one semicircle, naturally it is one full circle. So I can write that is pi r square, area of the circle. Plus let me come to this curved surface. I told you it is half of the curved surface area of the cylinder, full cylinder. You know it is 2 pi r h, that is the CSA of a cylinder. So here you will get pi r h. 2 pi r h divided by 2, you will be getting pi r h. So now you have added the area of the base rectangle plus area of two semicircles plus area of the curved surface. So let me write it properly. I will get 2RH plus pi r squared plus pi RH. This will be the S now. Now, you know H in terms of V and R. So let us substitute. So what will we get now? We will get here 2R into H is 2V by pi r squared plus Here there is no h, write it as it is. Here pi r into, in the h part you can write 2v by pi r square. Okay. So now let us simplify it a bit. Now here we will be getting 4v by pi. This r and r squared, one time it will get cut, I will get an r. The second term let me write as it is. Here pi and pi will go, one r will go, that will be 2v by r. To write it more properly, which will be easy for us to differentiate, I will write here 4v by pi, you know it is a constant. I will write this as r power minus 1. The second one, it can be as it is. Coming to the third part, it is 2v into r power minus 1. So now if you look at the s, you have v as constant and r is the only variable. So now this s should be minimum. That is what is given in the sum. So you know, for s to be minimum, there are two conditions, isn't it? For s to be minimum, there are two conditions. So let us write the two conditions now. For s to be minimum, first condition, you know, it is ds by dr is equal to 0. The second condition, because it is minimum, d square s by dr squared greater than 0. So we have to now find the two derivatives. So yes, let me write here again so that it will be easy for us. 4v by pi r power minus 1 plus pi r squared plus 2v r power minus 1. So now let us differentiate it. So first ds by dr is equal to, write the constant as it is. R power minus 1, when you differentiate, you will get minus 1 by r squared. Here you will get 2 pi r. Here 2v into minus 1 by r squared. This is the first derivative. This can be written as minus 4v by pi r power minus 2 plus 2 pi r, here minus 2v r power minus 2. Now the second derivative, d square s by dr squared is equal to minus 4v by pi r power minus 2. When you differentiate, you will be getting minus 2 r power minus 3. So I can write like this. The second one, you will get 2 pi. Here minus 2v into minus 2 by r cube, the same thing, okay? Because this is also r power minus 2, that is also r power minus 2. So here we can write this as minus into minus plus 8v by pi r cube plus 2 pi plus 4v by r cube. Just if you look at the terms, everything is positive. You know v is positive, pi is positive, r is positive. No need for any substitution. Straight away I can say this is greater than 0. So the second derivative part is already over. Now let us go to the first derivative. Let me equate it to 0 and find out what I get. So let me take the first derivative. So I get now ds by dr is equal to minus 4v by pi r squared plus 2 pi r minus 2v by r squared. Okay, this we are equating it to 0. Let us keep this positive here. I will take the other two terms to the other side. So I will get 4v by pi r squared, okay? Then plus 2v by r squared. So this is what I am getting now. Now I can take here pi r squared as common. That is denominator, I will take the LCM. So here I will get pi r squared. So I will get 4v plus 2v then 1 pi. Let me take this pi r squared here. So I will be getting 2 pi squared r cube, that is equal to 4v plus 2v pi. Now Here I can take one 2v common, 2v into 2 plus pi, right? Now this 2 and this 2 you cut. Now you have a v here. This v, you know the formula already. This v is nothing but 1 by 2 pi r squared h. Write this 2 plus pi as it is. Here you have pi squared r cube. Okay. So now this pi squared you have here. Here you have a pi. So 1 pi I can cut. Right. Now I have r squared. I have r cube. So this will go. I will get an r. Now this 2 you can take it to this side. So you will be now getting 2 pi r will be equal to, okay, the 2 I am taking this side. I will be getting 2 pi r is equal to, here I have h into 2 plus pi or pi plus 2, both are same. So I am writing that as pi plus 2. So now you want this h you keep as it is. Bring the 2r here. h by 2r. Okay. Here you have pi by pi plus 2. So this fraction we can express as a ratio. So I can write h is to 2r is equal to pi is to pi plus 2. This is what we want to prove. So now you got the proof part. Already the second derivative we have told it is positive. So now we can write the conclusion. So what is the conclusion? When the TSA, okay, when the TSA is is minimum, when the TSA is minimum, h is to 2r is equal to pi is to pi plus 2. We have proved this. This is the conclusion. So this sum you have actually learnt about the Hof cylinder and how it will be and what is the total surface area and all. So each sum in Maxima Minima, no, you will be learning some new concepts. So that is very important. So hope the sum is clear to you. You can subscribe and you can click the bell icon to get further notifications. Thanks for watching the video. If you have any doubts, if you want any other specific sum to be dealt with me, you can please write it in the comment section. Thank you.